Children, it is a continuation of the chapter Chemical Reactions and Equations, and the solution of the exercise of the chapter is continued. The question number 8. What is that question? Write the balanced chemical equation for the following and identify the type of reaction in each case. You know the different types of chemical equations: chemical combination, chemical decomposition, displacement reaction, double displacement reaction, etc. The first reaction A is potassium bromide. Potassium bromide reacts with barium iodide to give potassium iodide and barium bromide. It is a given reaction. It is a word equation, and we have to write the equation which is balanced. Chemical equation we have to write. And you know what is the molecular formula of the potassium bromide? Potassium bromide is a compound. Its molecular formula is KBr. KBr. It is an aqueous solution. Plus barium iodide. Molecular formula of barium iodide is BaI2. It is also aqueous solution. It is mentioned. Next, the products are, these two are the reactants: KBr, potassium bromide, BaI2, barium iodide are the reactants. They react with each other to produce potassium iodide. Potassium iodide, that is the molecular formula of potassium iodide is Ki, plus barium bromide, BaBr2. The molecular formula of barium bromide is BaBr2. Now you check whether it is balanced or not. If it is not balanced, we have to balance it. And see here, I2 is there, I is there, and you write 2Ki. 2Ki, and potassium becomes 2 here. Here only one potassium atom is there. So here also you write 2KBr. And 2Br, 2 atoms of bromium. Here Br2, 2 atoms of bromium you got. And barium, single atom on the reactant side and single atom on the product side. In this way you got the balanced chemical equation for the given reaction. And what type of reaction it is? You know that here potassium and barium are exchanged here. That is, the potassium is replaced by barium and barium is replaced by potassium. Similarly, bromine is replaced by iodine and iodine is replaced by bromine. As the displacement is there, we can say that here the group of atoms or ions are exchanged. Therefore, you can say that it is a double displacement reaction. Type of reaction is here. What is that? Double displacement chemical reaction. It is a double displacement reaction. Now the second reaction. What is that second reaction? Zinc carbonate produces zinc oxide and carbon dioxide. And here you observe what is the molecular formula of the zinc carbonate? That is ZnCO3. ZnCO3 is the molecular formula of zinc carbonate. It gives zinc oxide. What is the molecular formula of zinc oxide? ZnO plus carbon dioxide. You know the molecular formula of carbon dioxide is CO2. And observe the reaction. Verify whether it is balanced or not. Now you verify whether it is balanced or not. Count the number of atoms. And here O3, number of oxygen atoms are 3 on the reactant side, and on the product side also 2 plus 1, there are 3 oxygen atoms and 1 carbon atom on the reactant side and 1 carbon atom on the product side. Zinc also 1 1. So here it is already balanced chemical equation. And what type of chemical equation it is? Here how many reactants are there? Only one reactant. One reactant gives 2 product. One reactant gives 2 product. So it is a decomposition reaction. It is a decomposition reaction. So you write what type of chemical reaction it is. Type decomposition reaction. One reactant gives 2 or more products. Here 2 products are formed. If one reactant gives 2 or more products, then the chemical reaction is decomposition reaction. So what type of chemical reaction it is? It is a decomposition reaction, as one reactant gives 2 products. Next you come to the third reaction. Hydrogen plus chlorine gives hydrogen chloride. Hydrogen plus chlorine gives hydrogen chloride. It is a word equation. You write the chemical equation. What is the, the symbol of the hydrogen is H, and the molecular formula of hydrogen is H2, plus symbol of chlorine is Cl. Molecular formula of chlorine is Cl2. Hydrogen is an element. Chlorine is also element. Here the 2 reactants are elements. These 2 elements combines to form hydrogen chloride. Hydrogen chloride. What is the molecular formula of hydrogen chloride? That is HCl. Hydrochloric acid. Hydrogen chloride is nothing but a hydrochloric acid. And count the number of atoms, whether it is balanced or not. If it is not balanced, we have to balance it. H2, H is there. So there is no equal number of carbon atom. Cl2, Cl is there. Cl atoms are also not equal. Then you have to balance it. H2, Cl2 gives HCl, means here we can balance it by writing 2 HCl. Here on both the side you got equal number of atoms of each element. And what type of reaction? It is a, here 2 elements combines to give one single product. Then what type of chemical reaction it is? It is a chemical combination. Mention the type. Type of reaction is, it is a chemical combination. It is a combination reaction. Right? It is a combination reaction. Combination reaction. Next you take the next equation. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Here magnesium is a metal, that is an element. Hydrochloric acid is a compound, and in the product side magnesium chloride is a product, hydrogen is a metal. And write the chemical equation. What is the symbol of magnesium? The symbol of magnesium is Mg plus. And what is the symbol of hydrochloric acid? That is nothing but hydrogen chloride, HCl. Gives magnesium chloride, that is MgCl2. MgCl2 plus hydrogen. And you can write it is a solid, Mg is a solid, HCl is a aqueous solution, and MgCl2 also aqueous solution, H2 is a gas. You can write it and try to balance it. Mg is there, but here Cl2 is there, here Cl is there. On the reactant side only one atom of chlorine is there, and on the product side two atoms are there. To balance it, what you have to do? Write 2 here. And H2 is there, you got H2H, here also you got H2, so hydrogen atoms are also balanced. In this way you got the balanced chemical equation. If you want to write the state, then you also write the state. Mg is a solid, you write here solid, HCl is a aqueous solution, MgCl2 is also aqueous solution, and hydrogen is a gas. Then what type of chemical it is? Chemical reaction. Here you can observe that Mg replaces hydrogen from hydrochloric acid solution. So here you observe hydrogen is displaced by magnesium, then it is a displacement reaction. One element is displaced by the other element from its solution, so you can say it is a displacement reaction. Then you write the type, displacement reaction. Displacement reaction. So now the 9th question, what does one mean by exothermic reaction and endothermic reactions? Give example. What does one mean by exothermic and endothermic reactions? Give examples. You know that constituent elements in a compound are bound by chemical bonds. During a chemical change, when bonds between the constituent of the reactants are broken, energy is consumed, whereas energy is given out when the bonds are formed, as in the case of products. Thus, depending on whether overall energy is given out or consumed, the reaction is either exothermic or endothermic. So, what is exothermic reactions? Chemical reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Here, the chemical reaction in which heat is released along with the formation of the products are called exothermic chemical reactions. You can give many examples. So, let us take some examples. Calcium oxide reacts with water to produce slacked lime, that is calcium hydroxide, releasing large amount of heat. The chemical reaction is as follows. Calcium oxide reacts with water to produce slacked lime, which is calcium hydroxide. In this reaction, large amount of heat will be liberated. You note down that reaction. Next, you take carbon reacts with oxygen to produce carbon dioxide, releasing large amount of heat. This is also an exothermic reaction. Carbon reacts with oxygen. The product is carbon dioxide and heat is also liberated in this reaction. So it is exothermic reaction. Next, burning of natural gas. When CH4, the natural gas, burnt with oxygen, carbon dioxide and water produces together with the liberation of large amount of heat. Next, respiration. Respiration is also exothermic reaction. Here the food which is converted as a glucose reacts with oxygen, liberates carbon dioxide and water, produces carbon dioxide and water, and in this reaction large amount of energy is liberated. You know that energy we get by the food, that is by the respiration. Here in the digestion the food is broken down into glucose. That glucose reacts with the inhaled oxygen, that is in the respiration, and the products are carbon dioxide which is given out while breathing, and water also forms, and in this reaction the energy is liberated, and the energy which is liberated is used by us to do work and activities in our day-to-day life. Next, about endothermic reaction. So what is endothermic reaction? The chemical reaction in which energy is absorbed. It is the opposite of exothermic. In this reaction energy is absorbed together with the formation of the product, and it is called the endothermic reaction. Example, here silver chloride turns grey in the presence of sunlight. Silver chloride turns grey in sunlight. The reaction is 2AgCl in the presence of sunlight gives 2Ag plus Cl2. This is endothermic reaction. Here the sunlight is used. Energy is used, energy is absorbed. So it is endothermic reaction. Similarly, silver bromide turns grey in sunlight. Here also the reaction is done with the absorption of energy. So this is also an example of the endothermic reaction. Next, formation of nitric oxide. Formation of nitric oxide is also endothermic reaction. Nitrogen reacts with oxygen in the presence of by absorbing the heat. So it is endothermic reaction, formation of nitric acid. Next, photosynthesis. Photosynthesis is endothermic reaction. You know that plant uses sunlight to produce their food by using carbon dioxide and water. This is one of the example of the endothermic reaction. Carbon dioxide reacts with water in the presence of sunlight, produces glucose and oxygen. So this is the chemical reaction which takes place by using the energy of the sun. So it is endothermic reaction. Next, decomposition of calcium carbonate. When calcium carbonate is heated, calcium oxide and carbon dioxide will be produced. Here the energy is consumed, energy is absorbed. So it is also endothermic reaction. The next question, 10th question. Why respiration considered an exothermic reaction? Explain. It is already discussed that respiration is a exothermic reaction. Respiration is a exothermic reaction and photosynthesis is a endothermic reaction. In respiration what happens? Here energy will be liberated. So you know that during digestion food is broken down into simpler substances like glucose. For example, rice, potato, etc. are made up of carbohydrates. These carbohydrates are further broken down into glucose after the digestion. During respiration, this glucose combines with inhaled oxygen and oxidized. During this reaction, energy will be released. See the reaction. Glucose reacts with oxygen to produce carbon dioxide and water with the liberation of energy. As energy liberates in this reaction, it is a exothermic process. Thus, respiration is an exothermic process. That is the answer here. Next, let us take the 11th question. Why are decomposition reactions called the opposite of combination reaction? Write equations for these reactions. Here, decomposition and combinations are opposite reactions. In decomposition, one single reactant gives two or more products, and in combination, two or more reactants combines to give single product. The decomposition reaction is the opposite of combination. In a decomposition reaction, a single compound breaks down to produce two or more simpler substances. For example, you can give mercury oxide on heating decomposes to mercury and oxygen. In combination, two or more substances simply combine to form a new substance. You can give the example, simple example, magnesium combines with oxygen to give magnesium oxide. So let us write the answer here. The decomposition reaction is the opposite of combination. Because in a decomposition, reaction, a single compound breaks down to a single compound breaks down to produce two or more simpler substances. Produce two or more simpler substances. Simpler substances. Example you can give. Example, mercuric oxide on heating decomposes to mercury and oxygen. Write the chemical reaction. 2 HgO gives 2Hg plus O2. This is the chemical decomposition. Mercuric oxide decomposed into mercury and oxygen. Next, here in combination what happens? In combination, right? In combination, reaction, two or more substances combine to form a new substance. Example, you take magnesium combines with oxygen to give magnesium oxide. The chemical equation is 2Mg plus O2 gives 2MgO. So in this way, in decomposition, single compound break down to produce two or more simpler substances. In combination, two or more substances combine to give a single substance. So in decomposition, reactant is single. In combination, product is single. That is the difference here. Therefore, one is the opposite of the other. 12th question. Write one equation each for decomposition reactions where energy is supplied in the form of heat, light and electricity. For heat we have to give one chemical equation, and for light we have to give one, and for electricity also we have to write one chemical equation. Here we have to write three chemical equation, one for each. So first one, to take decomposition reaction where energy is supplied in the form of heat. In the form of heat. The reaction is, you can write MgO on heating gives Mg and O2. Here we have to write the equation. So write only the equation. That is 2MgO on heating gives 2Mg plus O2. Here it is a solid. It is also solid. It is gas. One example is over. Here on heating MgO gives Mg and O2. Second, decomposition reaction in which energy is supplied in the form of where energy is supplied in the form of light. In the form of light. You can write silver bromide or silver chloride under the presence of sunlight turns grey, that is turns to silver. Silver bromide or silver chloride, you write. The reaction is 2AgBr, that is solid, under the presence of sunlight. You write light turns into silver and bromine. Here both silver and silver bromide are solid and bromine is a gas. That is the example for the decomposition reaction where energy is supplied in the form of light. The next third one, decomposition reaction where energy is supplied in the form of electricity. You know the example, electrolysis of water, that is water decomposed into hydrogen and water, hydrogen and oxygen. Water decomposed into hydrogen and oxygen by passing the electric current. So you write electricity. Here both hydrogen and oxygen are gases and water is a liquid. Passing the electric current through the water, it decomposes into hydrogen and oxygen. These are the examples here. One is for heat, other is for light, and third one is for electricity. 12th question. What is the difference between displacement and double displacement reactions? Write equations for these reactions. In displacement reaction, metal which is more reactive displaces the metal which is less reactive from its solution. But in the double displacement reaction, two reactants in solution exchange their ions. So let us write here. In displacement reaction, metal which is highly reactive, metal which is more reactive displaces a less reactive metal from its solution. In double displacement, in double displacement reaction, two reactants in solution, solutions exchange their ions, In the displacement reaction, one metal will be in the form of element and other is a compound in a solution, and metal which is more reactive displaces a less reactive metal from its solution. In double displacement reaction, two reactants in solution exchange their ions. Now let us write the example here. Fe plus CuSO4, that is in aqueous solution in water, gives CuO plus FeSO4, that is also aqueous solution. This is a solid. Here Fe is more reactive than copper. This highly reactive Fe, the Fe which is more reactive than copper, displaces copper from its solution. That is the example for the displacement reaction. And for this double displacement, you take AgNO3, which is the aqueous solution, plus NaCl, gives AgCl plus NaNO3. So let us write AgNO3 plus, that is the aqueous solution, plus NaCl, which is the aqueous solution, reacts with each other to give AgCl aqueous solution plus NaNO3. This is the aqueous solution. You know the reaction already. This is the difference between the displacement reaction and double displacement reaction. Here Ag ions and Na ions exchanges. Similarly, NO3 ions and Cl ions exchanges.